welcome to 4C, which is geometric sequences and series. 4C is actually broken up. There's 4C, D, and E. I want you to take the notes for all of it. We'll see if we can get it done in a reasonable time. So, first one, determine if the sequence is geometric. Geometric means it's multiplied. Arithmetic was adding. Here's multiply. So with arithmetic, you had to subtract second term minus first term. Geometric, you divide. Second term divided by first term. Or the third term divided by second term. Or even if it's given, the fourth term divided by the third term. Each one of these, if it is geometric, should come up with the same answer. Negative 20 divided by 4 is negative 5. 100 divided by negative 20 is negative 5. And negative 500 divided by 100 is negative 5. Awesome. So to determine whether it's geometric, you need all three of these have to be the same. So it is a yes, it is geometric. Find its common ratio. Now, before it was common difference. Now it is common ratio. So the common ratio is, we write it with just an R. And in this case, the R is negative 5 from here. So that's the common ratio. So that's example 1. Example 2, find the explicit formula. So this could be very similar to arithmetic. This is a geometric. You can see that so this is already telling us it's a series or a sequence of numbers. So if we take the second term divided by the first term, this comes out to be 5. If you want to check it just to make sure that you got it right, you do the third term divided by the second term, and you come up with 5 again. This is the common ratio. So the R is 5, and we need to use the explicit formula. So the explicit formula for the geometric, explicit formula is a sub n, a sub 1, which is the first term, times the ratio raised to the n minus 1. So in this case, we already have the common ratio. We know the first term. This is the first term here. And we need to know, well, with the explicit formula, we don't actually know what the n is. This is just a general formula. So let's do a sub n. You just write down a sub n. The first term, negative 3, times the r, which is 5, raised to the n minus 1. We don't know what n is, so we just leave it n. There's no simplifying you have to do in this case. Arithmetic, you have to simplify, but geometric, you do not. So that is just substituting in. That's the explicit formula. Now we need to evaluate each geometric series. So technically, what you just did was 4C, and this is the start of 4D. I still want you to take the notes, so keep going. So evaluating the series, there's another formula you're going to use for this. So this is a series that ends. So you're only adding up the first 6 terms. So this is, in this case, the formula used is S sub n equals the first term times in parentheses 1 minus r raised to the n all over 1 minus r. So we just have to figure out what the first term is. Oh, that's pretty easy. First term is negative 2. We have to figure out the common ratio. Common ratio, second term divided by first term, because it's geometric. It's geometric, you know it's multiplication. So this is the common ratio. What else do we need to know in here? We need to know n. N, well, we already have that. So let's just substitute them in. So the summing up of 6 terms, the first term is negative 2 times 1 minus r is 5 raised to the 6th power, all divided by 1 minus 5. So if you're going to put this in your calculator, I would recommend putting parentheses around the whole numerator and around the whole denominator separately, and you'll come up with the answer. So if you're going to enter it in the calculator, I would enter it in this way with parentheses. I actually have parentheses around the -2 also. So you put all that in, hit the end button, and it would add up to negative 7,812. So the sum of the first 6 terms in this series would add up to negative 7,812. So now we have to determine, if for the next 2 examples, if the geometric series converges or diverges. So we have to understand what converging and diverging mean. Converging, when you converge on something, you are getting closer to it. So it's close to a number in this case. If it diverges, if you diverge away from something, you're getting further and further away. So it's getting further away from numbers, from a specific number. So another way to look at this, diverging, if it diverges, the numbers are getting bigger. As the series goes on, the numbers get bigger and bigger. If it converges, the numbers get smaller. So, 2 ways to look at it. So, what we do, if you're looking here, this first one, example 4, goes 2, 8, 32, 128. Those numbers are getting bigger. So from 2 to 8, it's times, what, 4? The numbers are getting bigger and bigger and bigger. This would mean it diverges. Numbers get bigger and it goes away from a number. It won't add up to a number, it'll add up to infinity, which diverges. On number 5 here, I'm going to look here at if it converges or diverges. I can't tell right away what it multiplies by. So what you're going to have to do is you have to take the second term and divide by the first term. So let's do that. So if I type it into the calculator, parentheses around each fraction, hit enter, I see it's negative 0.5. So if you multiply by a decimal less than 1, the fraction, or it is going to get smaller and smaller and smaller. If you see 3 over 2 is bigger than 3/4. So the numbers are getting smaller. If that's the case, it converges. So this example 5 would converge. It converges on the number. Where you're going to use that is in number 6. We're going to evaluate each infinite geometric series. Infinite now. Infinite, this is technically where 4e starts. Well, maybe I'll lie. That's actually 4e is back up further. 4e is up at example 4. So that has to do with infinite. When it says ... on 4 and ... on 5, that means it goes on forever and ever and ever. Here it says infinite and it says a ... So its infinite series is e. And this is to evaluate. There's another formula to use for this. Series, that means added up. So you have to add these. So what you're going to do, and since it's infinity, there's a formula for this. S sub infinity It's the only formula you use anytime you see infinity. First term over 1 minus r. This only is used when the absolute value of r is less than 1. Meaning r has to converge on a number. It has to be a fraction. So to find r, you have to find the first term, which is easy. To find r, it's just second term divided by first term. So we do that on the calculator. And we get 0.25. 0.25, is that absolute value of that? Is that less than 1? Sure is. So that means we can use this formula. So we're going to use the formula now. Sum of the infinite series equals the first term, which is 2, divided by 1 minus, and the common ratio is 0.25. Put this in the calculator, and you're going to get what, if you added all those numbers up, you get exactly what it'll add up to. So you see here, put this into the calculator, put parentheses around the denominator, hit enter, and you get 2.6 repeating. So you can go to the math key and change it to a fraction. So it's 8/3. So you could put 2.6 repeating, as long as you have the line over the top with a 6, it's okay. I would prefer a fraction though, 8/3. So we're going to do the next one. Come to class with questions. Sorry I ran over.